Okay, so I'm going to talk about the loss function of this specific game. So this loss function only works for this super resolution game. So I will run through it quickly. If you want to visit it, you can see me. Okay, so the first thing we have here is like, remember yesterday we talked about this one, how to calculate the loss for discriminator. The first thing is that the real going to discriminator, get the real discriminator output, and the fake going to discriminator, get the fake discriminator output, and this one will be compared with the real discriminator output will be compared with the label 1, this is real image, and the fake is the label 0. And this one is used for a PC game, right? We passed through it. And the second way we saw it is the patch game, remember? The pics, they are compiled to picture on top of each other. And then they pass this one to the simulator. That's the second way. And this super resolution game, they bring up the idea that like, they don't want to compare the real discriminator output with label 1 and this one with 0. But rather than that, they want to calculate the difference between the real effect. Just a little bit confused right here. It's like they will get the difference between the real output and the fake output. When doing this, they can say how real the real image is compared to the fake image, okay? And how fake the fake image is compared to the real image. Okay? It's a little bit confusion. Right here, we just like get the real output and then we compare with the target image and say, hey, this is real or this is not real. But this loss function, they try to calculate how real a real image is compared to the fake image, and how fake the fake image is compared to the real image. Yeah. And that's the main idea of the loss function for this SR game. And in order to do it, and that's why the loss function we can see right here is slightly different from what we saw yesterday for the generator. Yesterday we have this loss function for the generator. So the generator only depends on the fake output as the classic loss function. It only depends on this value. It doesn't depend, like this real output doesn't give any information to minimize the loss function for the generator because it's not including here. But when we come to the idea that I just tell you earlier, the loss function become like this. Like this, and it include the note right here, and it include both of this. So now your generator is benefited by both the real output and the fake output. It's like stronger than only depends on one. So it's kind of hard to understand, but the main idea is just that they compare the real and the fake. How much real is the real is, how much fake is the fake. Okay. So let's jump into the implementation. Wow. So you don't need to really understand the code right here, but just for this project, I need this specific loss function. And the first one to compare how real the real image is compared to the fake image. And the other one is how fake the fake image is compared to the real image. And then you get an average of that. And right here, we have another parameter called gain loss coef. It's just like a lambda that you decided for your project. The same thing happened with the discriminator. And there's one concept when it comes to the super resolution problem is that if you only compare image and image, just like you compare pixel by pixel, So if you compare each pixel, it doesn't understand anything about the image as a whole, right? So what about the content image? Like, can it understand like the shape, the general shape of the image instead of pixel? Then we come to the idea of perceptual loss. There's one more component put into the loss. It's called perceptual loss. And this is really easy. You have the real output, and you have the fake output, and you're gonna pass it into a VGG 19, but you cut the top of it. Only produce the output from layer 20. And when you do that, it's going to give you something like this. It's going to give you something like this. So now, both of your image, it will give you the important feature from the image that you pass in. And now your model can understand the image more. They understand like the main area of the image, where's the edge, and the important content inside the image. And we do after this, we just perform a mean square error. We calculate the loss between the effect and the real after passing through the VGG. So that's one more component. Adding to the loss function to help the machine learn the content of the image better, other than pixel to pixel. Okay? And that's it for the loss function. It's very easy, I guess. Okay, and yeah, we pretty much done with the loss function already. So here I have a main training function, and everything right here just kind of an extension of the pre-train step I just have earlier in the morning. So I really want you guys to go through the notebook, look at the pre-train steps right here, and do the same thing with the training section. Setting up checkpoint. Yeah. For the main part, like calculate loss, I already have the code right here, so there's no confusion about the loss function. It's just almost the same with the framework. And then after this, you run it. Okay, run. And here's my notebook after I run for 60,000 epochs on VM. As you can see, like the loss function for generator, even though it's run like 8 hours, it's still going down, but very slowly. It starts at 180 right here, and then gradually reduce, and still going down until 111. Yeah. But there's a thing right here. It's like my generator is way overpowered discriminator. And the discriminator, like until the further epoch, the discriminator doesn't work anymore. It's like overfitting. The discriminator cannot, like, discriminator like almost zero. But we want discriminator to like go up. We want to maximize discriminator, right? So this kind of fluctuate right here. But at the end, I achieved a PSNR of like 81. Yeah, and this is pretty impressive. And I want to show you the process of it. It's like the image got into the model at a very early, maybe like at epoch 200, around that. So like this, very pale. And then after 100 epochs, the colors is like bringing back, it's brought back. And after that, the gang work on the color. You see like it's overexposed right here. And then it's try to get image. And here's the ground truth. Yeah. So the first thing they're gonna do is like they create they try to mark the main content with the help of the VGG, and then after that they work on the detail and the color of it until they get it done. Okay. So okay, let's try an image. You want to try? Slow. Okay, let's try to predict an image. See how it works. Run a prediction. Okay. Load the model. This image belongs to the validation set. It's like the computer has never seen it before. And this is the image that we want to do. Like the eyes is kind of like pixelated. Let me see the size of it. At the shape of like 430 and oh no, it's the size. Where's that? 510, and what we're gonna do is like upscale to 2000. Okay. Okay, it's gonna run for a while because the model is like really deep. Remember this morning? And this is our result of 2000 and 2000. Let's save it. Okay, what we're gonna have here. This one is the low resolution one. This one is high resolution. Let's zoom in. I love the eye here. We successfully upscaled the image and also brought back the pixel right here. Okay, so that's it for the project. Now you can improve your photos. So I think today is like this afternoon, my section is also the last lecture, also the end of lecture day for Tonga class. So I just want to talk to you guys a little bit. It's like, this is the Earth looking at from the space. So my first dream ever in my life when I was 6 years old, I told my mom I want to be an astronaut. Yeah, I want to be an astronaut because like I want to look at the Earth. I want to be able to look at the Earth, and it's weird that that dream like followed me until today. I still love everything about the Earth. I love image about the Earth, and what you love? And then I always have the will to do the things to make like the society and the environment where we are living a little bit better day by day. And when I remember the first time when I came to Coder School was on a lecture, not a lecture, like a workshop of a guy's name, this guy. The workshop of this teacher. He was from Chicago. He was from US, and he hold a workshop in Coder School. And the workshop is like, he was a visiting professor in Hanoi. And his work is to use machine learning and AI to improve the river and the canal in Saigon, so that the poor people who live around that area will have a better life. Because they're sinking, because of sea level rising. So he used machine learning to predict the sea level rising. So we bring the better life to the people. And it really inspired me. And that's why I took a leap of faith and I left my design job. I joined the coder school, and I really believe like someday I can make something beautiful, and I can, from the visual, everything, the image that we can see every day, I can use it and I can help our life better. So what I want to tell you guys here is that you have come a long journey. You have learned a lot. You have learned a lot, and the special things that you learn to facilitate the most awesome discovery of humankind up to date, which is the computer. And more than that, you learn something which is the vehicle for you into the future, which is machine learning and AI. Not a lot of people know about it. And moreover than that, you know something that the student who is actually studying machine learning in the college, they have not learned about it by CNN. Again, we talk about those topics. So you must aware that you have something that a lot of people do not have. So in the future, if you become a data analyst, you become a data engineer, or whatever you do, so please keep the wheel of learning and always be curious. Keep your curiosity about machine learning. And I hope you guys the best in the future. I just tell it today. Yeah. So